We now want to look at a principle called elasticity. And once again, this is really a topic for business or finance, dealing with money. What happens is when a company, well, let me give you a quick overview of what this is, and then we can work out some problems. A company makes something, and of course, whatever they make, they sell at a certain price. And oftentimes, the price they set will affect the demand. In other words, the demand is how much people want to buy the product. And then, of course, the price of the product, how much you sell, affects your revenue or how much money comes in, right? So that sort of makes sense. And what typically happens, a lot of times, if you increase the price of whatever you're selling because you want to sort of make more money, what oftentimes happens is the demand goes down. So you don't sell as many. But so you raise the price, so you're getting more money every time you sell an object, but you're not selling as many. So the question is, when it's all said and done, are you actually bringing in more money or losing money? It's not for sure. Other times, a company, they will decrease the price. So what happens typically when you decrease the price of something? You sell more, people want it more, the demand goes up. And then once again, the question is, okay, but looking at the bottom line, we decrease the price, so we're not making as much when we sell it, but we're selling more. So then once again, it's not clear whether this was a good decision or not. Elasticity is a quantity, and it's going to be something we calculate. Elasticity in the business world is something they calculate to try and maximize the revenue based upon the price. So what we're trying to do is we're saying, okay, let's do this. Let's try and find a price that allows us to bring in the most money. In other words, if we increase the price, we're not going to sell as much. If we lower the price, we're going to sell more. But both those cases, it's not always clear how it affects the amount of money we bring in. This thing called elasticity, in a sense, will tell us what we should set the price at to make the maximum amount of money. So obviously you can see that this is something that business people would like to know. And let me just give you a heads up. In your homework, my notation is going to be different a little bit than what you will probably see in the homework, just because anytime I have a problem where we talk about the price, I like to use the variable P just because it makes so much sense. So we're going to have the variable P. We're going to have what's called a demand function. And a demand function, capital D, demand function, sort of tries to predict how much we're going to sell based upon the price. So the demand function is D of P. So the demand, how much we sell, is going to be affected by the price. And you'll see what is going to happen when we work out some problems are. They will give us a demand function, which will be like an equation. And then they'll give us a price. And then the last thing we have is the elasticity, which we just call capital E. And it's also going to be a function of the price. All right, so let me go ahead and write to you what the equation is to calculate elasticity, and then we'll do some problems. I don't think you're going to find this very hard. So the elasticity, here's the formula. First of all, it's negative, which is interesting. Then you take the price that you're looking at. So the elasticity is based upon a price. So you choose a price you want to look at, and you plug it in this elasticity equation, and then it'll give you a number for the elasticity. Matter of fact, let me finish this equation, and then I'll explain a little bit how we judge elasticity. So negative the price times the first derivative of the demand function. So the demand function is going to be some equation. The variable is going to be P. We have to stick in here the actual first derivative. Obviously, this is why we're going over this in the calculus class, because now that we know how to take derivatives, we can solve this or do this kind of calculation. But then this is a fraction, and in the bottom is the demand function. So this is the formula to calculate the elasticity at a certain price. You plug in the price, you go get the first derivative of the demand function, plug in your price, do that calculation, take the original demand function, plug in the price, and this whole thing will then give you the elasticity. Now the elasticity you get the maximum revenue. Well, let me do it like this. Equals 1 that's what you want. So if you can find the price to plug in this elasticity equation, if you can find the price that causes the elasticity to be 1, then that's going to be the price for your maximum revenue. Matter of fact, in the problems we're going to do, one of the things they're asked us to do is to find the price where the elasticity is 1, which is the maximum revenue. Matter of fact, they call this when it's 1, they call it unit. I don't really care about this language, but just so you know. Now the other options are you calculate your elasticity and it ends up being less than 1. 0.5, 2 over 5, whatever. If it's less than 1, that price, we call it, the situation is it's inelastic. And what this tells you is a price increase will give a revenue increase. So when you calculate the elasticity and the elasticity is less than 1, that sort of says you probably need to raise your price, because you can raise the price and you're going to make more money. So this sort of tells you it's not ideal. Ideal is when the elasticity is 1. So you've got some room to quote unquote improve if your goal is to make some money. And then the third option is sometimes you calculate the elasticity and it's greater than 1. And we call this, they call this elastic. So less than 1 inelastic, greater than 1 elastic. If it equals 1, they call it unit elasticity. Once again, I don't care about these terms necessarily. It's not going to be on the test, but just so you can say you've seen it, there it is. So what's going on here? Here it says basically that if your elasticity says you're elastic, if you're going to raise the price, you know what's going to happen to your revenue? It's going to go down. So what you do is you have an equation of elasticity, you plug in the price you're looking at, and then you calculate elasticity. If it happens to equal 1, then you're perfect. If the elasticity is less than 1, that says, you know what, you should increase the price some because you can make more money. But if the elasticity is greater than 1, that says, you know what, if you keep increasing the price, you're going to make less money. You better drop the price. So this elasticity sort of tells you how you're doing, and it sort of allows you to figure out what price you should set to make the maximum revenue. All right, so let's do some problems. I don't think you're going to find these very hard. Now let me just show you. I think this is how your book will state it. I will write it once, and then I'm going to write it the way I like to do it. So my apologies if it confuses people. So typically, here's what they will do. Once again, a lot of notation is confusing. This Q, I think, stands for demand quantity. Once again, this is the last time I'm going to write Q. Here's how they write the problem in the book, and this is how you might see the homework. So this is demand function. They like to use X for the price. So they're saying, here's the demand function. And they're saying, look at the price of $125. Now, the way I'm going to do it, you're going to see what I do. First of all, I ignore the Q. I don't use this Q. Demand function, I like to make my variable P. This P stands for price. Just makes it clear to me. Therefore, for this problem, the demand function is 400 minus P. So this is saying, once again, the demand is how much of your product people are going to buy. And it's saying here, well, depends upon the price. You set your price, and then you can calculate how much you're going to sell. And therefore, we're going to look at the specific case where we look at a price of $125. So in this problem, they actually asked for 3 things. They first asked for the elasticity when you set the price $125. So let's do that. Here's the equation for elasticity, negative the price times the first derivative of the demand function over the demand function. Or just to make it very clear, since I'm going to look at elasticity when the price is 125, you have 125 equals negative 125 times the first derivative when I set P equal to 125 over the demand function when I set P equal to 125. As of right now, the one thing I don't know is the first derivative. So here's my demand function. Maybe let me just do it up here. What would the first derivative be with respect to P? First derivative of 400 is 0 minus P, this up being minus 1. It's interesting, there's not even a variable left in here. So therefore, the elasticity, when I set P equal to 125, is negative 125 times the first derivative when I plug in 125, well, it's just negative 1 over the demand function when I plug in 125. So basically I have 400 minus 125. Although actually, I sort of jumped ahead. This is part B. Let me just finish this calculation. So this negative cancel out. 125 over 275. If you reduce this, it should be like 5/11. So the elasticity when the price is 125 is 5/11. This was really part B. What they really want for part A is they want to go ahead and get an equation for the elasticity. So for part A, first derivative is just negative 1. The demand function is 400 minus P. So really what they want is the equation for the elasticity is P over 400 minus P. So that's the equation for the elasticity for this problem. When I specifically look at a price of 125 and I plug it in here, I'm going to get 5/11. And then part C, which is interesting, basically they want you to find P where the elasticity equals 1. So in a sense, they want us to go find the price that gives us the maximum revenue. So once again, here's my equation for elasticity. P over 400 minus P. I'm going to set that equal to 1 and then solve for P. That's the way I will determine the price that will give me an elasticity of 1, which is when I will maximize my revenue. So to solve this, I'm going to multiply both sides by 400 minus P. Now to solve this, I'll add P to both sides. 2P equals 400. Divide both sides by 2. So what I'm saying is, need to set the price at $200 to get the maximum revenue. So what's interesting, in part B, we looked at the elasticity of 125. It ended up being 5/11, which is less than 1. And if you look at our definition, what happens when the elasticity is less than 1? It says if you increase the price, you're going to get some more revenue. Turns out that's what happens, because we looked at 125, then we say, well, let's just go ahead and figure out where the maximum revenue is. That looks, it's a 200. So yeah, you're at 125. And by having this elasticity less than 1, it's sort of saying, hey, if you want to make some more money, you need to increase the price. It turns out you should increase it to 200. All right. So I don't think it's that hard. Let me do one more example. Then I think you should be in good shape for the homework. So let's do one with a little bit more involved equation. So once again, instead of x's, I'm going to replace x's with p's. That's just me. So here's my demand function. (100 over p plus 3 quantity squared). So initially, we're going to look at the elasticity when the price is 1. And then we'll try and figure out what the price should be to get the maximum revenue. So really, same problem, 3 parts. First part, part A, let's find the equation for the elasticity. Then part B, we'll plug in a price of $1, and part C, we'll find the price for the maximum revenue. So elasticity, once again, negative P times the first derivative of the demand function over the demand function. The first derivative here, it's not going to be so simple. Let's rewrite the demand function. I'm going to take this whole parenthesis. I mean, you could do the quotient rule. I guess I'd rather just bring it up to the top. And then I'm going to use the chain rule on this to take my derivative. So 100 minus 2. Copy down the parenthesis and subtract 1, and then multiply by whatever's inside the parenthesis, the derivative of whatever's in the parenthesis, which is just 1. So when it's all said and done, negative 2 times 100, I'm going to go and put this back on the bottom. So I believe that should be the derivative of this demand function. So I have everything I need to calculate the elasticity function. So negative P times negative 200 over P plus 3 cubed all that over the demand function, which is 100 over P plus 3 cubed. Or P plus 3 squared, sorry. Wow. That's pretty messy. What I need to do is now try and simplify. This is like, it's like a complex fraction. Sorry, I'm just taking a drink. Let me do this first. Got a negative P times 200. Just write it like this, 200P over P plus 3 cubed over 100 P plus 3 squared. Now, some of you, if you're comfortable with complex fractions, can sort of cancel and do stuff quickly, but just in case, those of you who aren't quite sure, when you have a fraction over a fraction, I can rewrite this. What do? You write down the top fraction. And then you multiply by the reciprocal of the bottom fraction. So you flip the bottom fraction, and that's what you multiply by. And now you can see I can do some canceling and reducing fairly easily. First of all, 200 over 100 reduces down to 2 over 1. P plus 3 squared over P plus 3 cubed. This goes away. And this just becomes P plus 3, or P plus 3 to the first. So it looks like when I'm all done, this will be my elasticity function, 2 over P plus 3. Now part B says, so go find the elasticity when the price is 1. So 2 over 1 plus 3, 2/4, which is 1/2. So they call this situation inelastic. Basically what they're saying is you can increase the price and increase your revenue. So what the last part is, find P so that elasticity equals 1. So find the price so the elasticity is 1, which is the price for the maximum revenue. So you simply take your elasticity equation and set it equal to 1. You solve this. So multiply both sides by P plus 3. I subtract 3 from both sides. Now I did this problem previously, thankfully, and this doesn't look like the correct answer. Wow. You may have caught this. You know what I forgot here? See, math teachers make errors too. I forgot this P here. So that means this isn't quite, well, turns out this answer, because 2 times P, and P is 1, just by dumb luck, this answer is actually still the same. But this one will definitely change. Because you know what? I was getting a negative, I was getting ready to get a negative price. I said, oops, can't have a negative price. I'm not going to pay you money for the product. So now I'll subtract P from both sides. And you get P equals $3. So that's the price you would set to get the maximum revenue. All right, sorry about that. But like I said, it happens to all of us. So that's a learning lesson, even for me. All right, so I don't think you'll find these elasticity problems too hard, hopefully. So good luck with your homework.